Hi, hello, my dear competitive aspirants. This is Venkanna. Welcome to VHL Academy. If you are a civil engineering graduate, you want to become an engineer, this video is for you. In this video, we are going to discuss about shear force and bending moment. The shear force and bending moment is the part of strength of material. It is also called as the solid mechanics. In this solid mechanics, this shear force bending moment is very important in all the competitive examination like SSC JE, APPSC AE, AW, TSPSC AE, AW, GATE, IAS and some other PSUs. This shear force bending moment is very important. In the civil and mechanical competitive examinations, without shear force and bending moment, there is no question paper. This is very important in our examination point of view. In this video, we are going to discuss about shear force and bending moment. This shear force and bending moment is occurs due to the transfer or lateral force applied on the beam. Yes, before going to discuss the shear force and bending moment, we have to learn the basics of shear force and bending moment. Right, so what is the beam? What is the beam? A member subjected to lateral load or a member is subject to transfer load is called as a beam. In the beam, due to the application of load, shear force is develops and bending moment is develops. See, beam. Yes, what is the beam? A member subjected to transfer or a member subjected to lateral load is called as beam. Right, so what is the beam? A member subjected to transfer load or a member subjected to lateral load is called as beam. Right, so on the beam, due to the loading on beam, both shear force and bending moment occurs. Yes, due to the loading on beam, for example, this is a beam. Due to the loading on beam, both shear force and bending moment is occurs in this beam. Right, so beam, a member is subject to transfer or lateral load, it is called as the beam. Due to the application of load, that is transfer load or lateral load, say both shear force and bending moment is occurs. Right, so in this beam, so what is the equilibrium equation? Because this equilibrium equation is used for calculation of both shear force and bending moment. Bending moment. What is the equilibrium equation? Equilibrium equations. What is the equilibrium equations? If you consider the first one is a one-dimensional member. One-dimension member. In a one-dimensional member, one-dimensional members, what is the equilibrium equation of a one-dimensional member? Alright, what is the example of one-dimensional member? The example of one-dimensional member is a tie. Tie is a tension member and a strut, etc. Right, so tie is a tension member and a strut is a compression member. So this tie and a strut both are the one-dimensional member. Right. See here, this is the tie. This is the tension. This is force. Tension force. Right, and this side also a tension force. This is called as the tie member, right? If you consider the strut, this is the member. On this member, load is towards the member. The load is towards the member. This is called as the strut. This is the strut. Right, so this is a tie. Tie is a tension member, and this is the strut. Strut is a compression member. This is one member, one-dimensional member. On this member, the load is applied towards the member. It is called as the tie. And this is one of the member, one-dimensional member. On this member, the load is applied so towards the member and here away from the member. Right, the member is applied away from the member, that means tension. Here the member is the load is applied on the member, that is towards the member, that is called as the strut. Right, on this one-dimensional member, what is the equilibrium equation? The equilibrium equation is summation of forces along x direction is equal to 0. The summation of forces along the x direction is must be 0. It is called as the one-dimensional member. Therefore here, how many equilibrium equations is there here? The equilibrium equation is only one equilibrium equation, right? Equilibrium equations. Equilibrium equation is equal to one equilibrium equation. Only one equilibrium equation. Right, so this is one-dimensional member, right? The load is acting away from the member. Here the load is acting towards the member. These both are the one-dimensional member only. For the one-dimensional member, the load, the summation of the all forces, summation of the forces along the x direction is must to be 0. Here only x direction, right? So this is the equilibrium equation of one-dimensional member. Only one equilibrium equation of this one-dimensional member. Right. And the equilibrium equations of a two-dimensional member. Next one is the equilibrium equation of a two-dimensional members. Alright, so 2D members, two-dimensional members. Equilibrium equation of two-dimensional members. Right. What is the example of two-dimensional member? Second one is the equilibrium equation of a two-dimensional member. Second one is for two-dimensional member, what is the equilibrium equation? So what is the example of the two-dimensional member? That is the example of the two-dimensional member is beams. Beams is considered as a two-dimensional member, right? Normally this is the beam. This is the beam, right? So this is length of the beam. This is length of the beam L, right? This is one dimensional and this is one more dimensional. That means this is the width of the beam B and this is depth of the beam D, right? So this is a two-dimensional member. So on this two-dimensional member, due to the application of transfer load or due to the application of lateral load, so what is the equilibrium equation? The equilibrium equation in this two-dimensional member is summation of forces along x direction is equal to 0. Second one is summation of forces along y direction is equal to 0. And one more is summation of moment summation of forces along the x direction is 0, summation of forces along the y direction is 0, and summation of forces along z direction is equal to 0. Along the z direction is equal to 0. Summation of forces along x direction is equal to 0. Summation of forces along the y direction is 0. Summation of forces along z direction is 0. This is x direction, this is y direction, and z direction. Alright, so here the summation of forces along the x direction is equal to 0. The summation of forces along the y direction is 0. The summation of forces along the z direction is 0. In the two-dimensional member, three equilibrium equations is occurs, right? So these are the three equilibrium equations. Alright, so three equilibrium equation. Summation of forces along the x direction is 0. Summation of forces along the y direction is 0. Summation of forces along the z direction is 0. These are the three equilibrium equations in two-dimensional member. Alright, next one is the equilibrium equation in three-dimensional member. Equilibrium equation in a three-dimensional member. Right. If you consider three-dimensional member, third one is 3D member or three-dimensional member. Alright, so in this three-dimensional member, what is the example of three-dimensional member? Right. Example of three-dimensional member is spatial members. What is meant by the spatial members? Example is machine parts ante machinery parts edaithe ante machine part antam, that is called as the spatial member. Alright, so spatial member. So in this three-dimensional member, yes, in the three-dimensional member, so machine part, so for example this is the machine part. For this machine part, so what is the equilibrium equation? That is, the summation of forces along the x direction is 0, the summation of forces along the y direction is 0, the summation of forces in z direction is 0. One more is the summation of moment along the x direction is 0, the summation of moment in the y direction is 0, the summation of moment in the z direction is 0. See here, therefore the summation of forces along the x direction is equal to 0, the summation of forces along the y direction is equal to 0, the summation of forces along the z direction is 0. Alright, and the summation of forces along the summation of moment, not forces here, the summation of moment along the x direction equal to 0, summation of moment along the y direction is 0, summation of moment along the z direction is 0. Here the number of equilibrium equation is 6 number of equilibrium equations. In the three-dimensional members, the equilibrium equation is 6 equilibrium equations. Alright? So here, once more remember this. What is the beam? A member subjected to lateral load, or the member is subjected to transfer load. It is called as the beam. Alright, so due to the application of transfer load, or due to the transfer load or a lateral load on the beam, shear force and bending moment is occurs. If you see the equilibrium equation, in this equilibrium equation, if you consider one dimensional member, that is strut or tie, in this one dimensional member, summation of forces along the x direction is equal to 0. That means only one equilibrium equation. We get only one equilibrium equation in 1D member. If you consider the two-dimensional member, in the two-dimensional member, the summation of forces along the x direction is 0, the summation of forces along the y direction is 0, the summation of forces along the z direction is equal to 0. The example of two-dimensional member is beam. Beam is a perfect example of two-dimensional member. Alright, so in the beam, so three equilibrium equation is occurs as a two-dimensional member. And if you consider three-dimensional member, in this three-dimensional member, the example one is spatial member. That means machine parts. Right, so machine part is the example of three-dimensional member. In this three-dimensional member, summation of forces along the x direction is 0, summation of forces along the y direction is 0, summation of forces along z direction is 0, and summation of the moment along the x direction is 0, summation of moment along the z direction is 0, summation of moment along y direction is 0. So in the three-dimensional member, 6 equilibrium equations we get. Due to the equilibrium equations, we calculate both the shear force and bending moment in this chapter. In the shear force and bending moment, this equilibrium equation is used to calculate shear force and bending moment. Thank you.